Well, hey students, it's Mr. Collins. This is my first go around at trying something new this year. We're going to try to do some of the lecture lessons on video at home where you can watch them at your own leisure, back it up if you need to, take some notes, write a summary, and write down any questions that may pop in your head so you can ask them in class the next day. First up, we're talking a little bit about the scientific method and the experimental setup. We've got several parts that we have to pay attention to when we are doing an experiment on something. And so we have the independent variable, the dependent variable, the control, the constants. That all begins with a question, but let's hold on to that and get back to it in just a moment. First up, the independent variable. That is the one thing that we are changing in an experiment. We are manipulating that. It is sometimes called the manipulating variable. And let's say we wanted to test out how much fertilizer affects how a plant grows. And so we were going to use different amounts of fertilizer. That would be our independent variable because that's what we're changing. And so we'll put that up there. Amount of fertilizer. Amount of fertilizer. Now the dependent variable is what responds to that. And so what we're checking here is how this affects the height of the plant. And so that would be our dependent variable. Height of plant. Now, of course, in this phase right here, this should actually fit your question. And so our question typically is formed, how does whatever this is affect whatever that is? And so in this case, how does amount of fertilizer affect plant height? And so there's our independent variable, there's our dependent variable. If you can get your question phrased like this, it makes it very easy because now we can think, what do we know about fertilizer? What do we know about how much, amounts of it, things like that. And so we can kind of make a hypothesis. Well, I think more fertilizer is going to mean more plant height, or more maybe mean less. I don't know. Whatever you come up with. And then you test it. That's what we do with the experiment. Now, to test this cleanly, we have to do a couple things. First of all, we have to have a control. The control group does not have the independent variable in it. And so that would be like a plant with water only, no fertilizer. Pardon me. Let's see. Plant with water only. Now, everything else has to be kept constant or the same so that it doesn't interfere with our results. So that means we got to use like the same amount of water. So we'll put this amount of water. Same type of fertilizer. Same type of plant. And we can go on and on and on. Time frame. That would be important. You wouldn't want to measure one plant for a week and another plant for a month. That'll throw you off, etc. And it keeps going. And so now, we're keeping everything constant. We're changing the amounts of fertilizer. And we're going to see how that affects height. Now we need some data. So I'm going to make up some data right here and just pretend that we measured it, okay? let's say we've got a little data table where we've got amount of fertilizer and height right here. At 0 grams, let's pretend we measured it and we found 10 centimeters. And then at 5 grams, it was 12 centimeters. Let's say 10 grams, it was 14 centimeters. 15 grams was 16 centimeters. 20 grams. A nice little pattern there. Can you guess what our graph would look like there? I bet we're going to have a straight line. Let's graph it and see. I'm going to have to shift us down a little bit here so the camera may fall. I hope not. Yep, there it goes. Alright, we've gathered our data. Now let's make a picture of it so we can kind of see what's really going on. And now we got to draw an effective graph. And a ruler is a good thing to have for that. Because you need a y-axis. You need an x-axis. And you got to make sure you've got even marks. That didn't go over very well because I wasn't paying attention to where I was making my marks, but here we go. We can use your ruler to get them nice and even. Typically, this is your origin, and your scales will be zero, start at 0. Now, here you always want your independent variable, so that's amount of fertilizer. And we measured it in grams, so we need to have that on there. You always need to have your scale good and labeled. We went up by 5s. So let's just put that 5, 10, 15, 20, 25, 30, etc. I'm going to use the same increments I used on the X. You don't necessarily have to. But it's usually a good idea to kind of make the graph look nice and neat. Let's see, we went up by 2s there. I can't make just a jump from 0 to 10 and then go 12, 14, 16, 18. That doesn't make a good graph. So let's go up by 5s. 2, 4, 6, 8, 10, 12, 14, 16, 18. Hey, that'll work out just right. Let's go up by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18. Again, that's just a bunch of numbers if we don't label it and give it a title. So here's our height of the plant. And we want to put our unit with it, centimeters. Okay, now let's plot our data. At 0 grams, we actually got 10 centimeters. At 5 grams, we got 12. At 10, we got 14. And of course, 16, and we topped it off at 18. Now draw your best fit line through there, and it may not always line up perfectly, so just get your line as close as possible. Something like that. Now you've got a nice slope. You can measure that slope, and that'll give you your y divided by your x. Remember, you could pick two different points off there, do y2 minus y1 divided by x2 minus x1. And that will determine how steep your slope is. And that, depending on the graph, will tell you different things. Now our graph is missing one final thing, a title. People need to know what they're looking at. In this case, the question works perfectly. How does a mound of fertilizer affect plant height? Or you could say amount of fertilizer versus plant height. Draw good graphs. You've got to be skillful when you do your graphs. The end of course exam will demand it. Well, summarize that. Go back and rewatch it. Take notes. Do whatever. Write down any questions you have and bring them to class tomorrow and discuss with your peers and me. See you then.